Doc. His comment was we had a lot of well-people meetings and a sick doc. And he said he hated science.
The tour buses pass the headquarters building, the administrative center for all spaceport activities, and the O&C building where Space Lab is processed.
You develop a healthy respect for what an orbiter can do. You're talking about a highly durable space plane that can fly 25 times the speed of sound. This bird can fly backwards and upside down and could carry this bus in this cargo bay.
It can even carry other spacecraft like satellites and scientific deep space probes, so they can be deployed in space. There are two basic tasks that have to be completed in the VAB. The pieces of the shuttle have to be lifted from a horizontal to a vertical position.
From the land or the sea, it is difficult not to see the Vehicle Assembly Building. It is referred to simply as the VAB. In this immense building, the huge Saturn V moon rocket was prepared for launch. Today, the space shuttle and its components are refurbished, assembled, and prepared for flight here. The bicentennial symbol and the American flag were painted on the building in 1976. Each star measures 6 feet across, and the long stripes are about 210 feet in length.
Charlie, as an astronaut, you know better than anyone that we have to perform our work perfectly. We have to protect the safety of the crew. That's why, for many of the most critical systems, for instance, the life support system, we have 2 complete backup systems. And if one little thing is wrong with either backup system, that orbiter is not going to leave this building.
Al, of all the thousands of tasks you perform on an orbiter, what's the most time-consuming?
Probably inspecting and repairing thermal tiles that cover the orbiter. There are more than 20,000 of them. We have to make sure every micro-inch is perfect. That's because the tiles act as the orbiter's skin, protecting it from the cold of space, which can reach 250 degrees below zero in the shade, to the tremendous heat of re-entry. When you're coming back into Earth's atmosphere, Sally, and hitting 2,500 degrees, we don't want any weak spots in your orbiter.
I appreciate it, Al.
Now they're talking about these buildings right here on the right, number 1, 2, and number 3 in the back. Endeavor's over there in Hangar 1. Columbia's right here in Hangar 2. Discovery's on the pad getting ready for its launch on June the 2nd. Going to go off at 6:30 in the evening. So if any of you folks are going to be around here on the 2nd of June, try to make arrangements. You can buy tickets in advance for these tour buses, and you get on the tour buses and they'll take you over on Cape Canaveral. You see the launch from over there. So if you've never seen a shuttle launch, try to get tickets in advance for these buses and come and see it. It's well worth it, folks. The tape now is going to talk about the big machine on the right over here, the transporter, largest land vehicles in the world.
Now, if you remember, a while back Al asked a question. How do you move 12 million pounds of shuttle and platform to the launch pad? If you look over to your right, you'll see the answer. The crawler transporter is the biggest tracked vehicle in the world. A crawler weighs about 6 million pounds, unloaded, and has a surface area about the size of a baseball diamond. 2 large diesel engines, which power electrical motors, turn its treads. Operating a vehicle of that size takes a highly trained crew of about 20 engineers and technicians.
Now, these are the largest land vehicles in the world. They were built back in 1960 up in Ohio at the Marion Shovel plant. And after they got them built, they couldn't bring them to Florida. They were too big. So they took them apart, sent them down here in pieces on railroad cars, sent a crew down here, rebuilt them right here. We have this one here, and the other one's out by the Gantry. We're going to let you off the bus. They stand at 20 feet high. The body goes up 26 feet high. Each one of the large track sections are 41 feet long. They're 10 feet high and 7 feet wide. There are 57 cleats on each one. The cleats weigh a ton apiece. The wiper blade on the glassed area where the driver sits is 5 feet high. The driver sitting up there doesn't have a steering wheel. He has a large panel board in front of him. Whatever he wants that machine to do, they just push buttons. They have computers, and the center machine will do all the work for them. And in the middle of that machine, we have an engine room and a computer room. Fuel capacity is 5,000 gallons of fuel, and when they're moving the shuttle up to the pad, they'll get 18 feet per gallon of fuel loaded, 35 feet per gallon of fuel empty, and you think you've got a problem. Now up here on my left, the big brown building is where they remove the booster rocket segments from these yellow railroad cars when they come in here from the manufacturer. The railroad cars will come into us 8 at a time. Each one carries a booster section. They take them in this building 2 at a time, open them up, take out the booster rocket sections. They're stored in the building way in the back there to the left, and the one in front of us up here on the left. At night, when there are no tourists here and less employees, that's when they move the 8 sections over into the vehicle assembly building, and that's where they assemble them. They stackpile them on top of each other like a child stackpiles blocks. Everything is done inside the VAB at night. Once they get the 2 booster rockets assembled, then they bring in the big brown tank, the external fuel tank. That's brought in second. They connect that up. The last thing to be brought in is the spaceship itself. They bring that in, they assemble that to the brown tank. Once it's all connected up in the building, the big machine goes in the building, gets the big platform and the space shuttle, moves it to the pad 3.5 miles away. It'll take the large machine 6.5 hours to move the shuttle out of the vehicle assembly building out to the launch pad.
At the Cape, hundreds of workers were standing by to get the shuttle ready for its next flight. The orbiter was raised to a vertical position inside the giant assembly building. All systems were carefully checked and rechecked. Engines were taken apart and rebuilt. Solid boosters and a liquid fuel tank were attached. Finally, the shuttle began to move slowly toward the launch pad on the same giant crawler used by the Saturn V.
The crawler transporters were built by the Marion Power Shovel Company of Marion, Ohio. And the parts were manufactured there, then they were shipped here by rail and truck and put together on the site where the one there is parked. We have 2 of them. The driver's station is located there on the front corner. You see the glass cabbing, and at the other end of the vehicle, left front corner, as you face the vehicle, you'll find another. So they don't have to turn the vehicle around. It moves just as fast in one direction as it does in the other. The transporter carries a large structure that we call the mobile launcher, which is a steel platform. Actually, in some cases, it looks like a building, but because it is 2 stories thick. And they place it on top of the 2 rows of steel pedestals. Of course, that large tank on the yellow trailer would have to be moved out of the way if they wanted to place it on top of this. And by using its hydraulic jacks, the crawler transporter's hydraulic jacking and leveling system, it raises the body of the transporter up, lifting that launcher above those pedestals, drive in between them, and when it reaches the right location, the crawler transporter will lower the hydraulic jacks, and that structure will sit on top of the 2 rows of steel pedestals, and then the crawler transporter comes out from under it. We have 3 of those mobile launchers, and 2 of them is inside the big building to your right, the VAB, the tall building.
An incredible machine of awesome size is used to move these giant space vehicles. It can carry 12 million pounds, and its deck is about the size of an infield of a professional baseball diamond. The crawler itself weighs 6 million pounds. The crawler's average speed is 1 mile per hour, and it requires a crew of as many as 26 to operate it. In 1977, the American Society of Mechanical Engineers designated the transporter as a National Historical Mechanical Landmark, a fitting tribute to an amazing machine.
Now when I turn the tape on again, it's going to talk about the white building over there with the louvered windows. That's the Launch Control Center, or the firing rules for pad A and B. Everything is controlled from there 3.5 miles away for safety.
Directly adjacent to the vehicle assembly building is the Launch Control Center. The Launch Control Center is the electronic brain of Launch Complex 39. It's the home base of a complicated computer system that oversees the entire checkout and launch process of the space shuttle. This launch processing system has greatly reduced our turnaround time between missions.
3 days before liftoff, this place gets extra busy. That's when countdown for launch starts. About 200 members of the launch team are stationed in the primary firing room, checking and double-checking every system on the shuttle. We've got 4 firing rooms in the Launch Control Center, 2 primary and 2 support.
The Launch Control Center oversees the launch until the moment the shuttle clears the tower.
Got 4 good HPUs. 4 good. I'm gonna get the last doors open. I got the doors. All the picks are up.
Platforms in the VAB there with the doors open.
Over the sand. So our engineers designed a very special roadway. The stone road with the crawler the boober rock, crushed stone, and compact fill, going down more than 7 feet deep. The crawler transporter travels on is called the crawlerway. It's 130 feet wide, about as broad as an 8-lane highway. To support the crawler's tremendous weight, the crawlerway has 4 layers of river rock, crushed stone, and compact fill, going down more than 7 feet deep.
It really is quite a remarkable sight to see a crawler making its way down the crawlway at the stately pace of 1 mile an hour, with a fully assembled shuttle sitting on top.
This is where all the major networks come to televise the launches. Also, if you look over at the American flag over there and look at the bottom of the flagpole, just a little bit to the left of that, you'll see a gray, oblong-looking box. That's the actual countdown clock that we see on television when there's a launch. We'll see that this afternoon. Also, this weird-looking yellow trailer on the left here, this is what they call the barge turn basin. They bring the external fuel tank in from Louisiana on barge, and they all load it on that trailer and transport it from there across the street to the VAB. It's too big to bring in any other way, so that's water is the only way of getting it here. Before we used to pull into the right here and park for about 10 minutes. People could get out and take a picture. That's all there was. Still not be able to see all of it. No comparison at all, folks.
In other words, a spacecraft launched from right over there is someday going to map the exact boundaries of our solar system.
That's right, Al.
We're now approaching the LC-39 observation gantry. The 54-foot tower to your right is located less than 6,500 feet from launch pad 39A. You'll have the opportunity to get a true bird's-eye view of both launch pads, as well as many pads to the south at the Cape Canaveral Air Force Station. Be sure to visit the exhibit gallery.
The countdown demonstration test with the flight crew was conducted just a few weeks ago. Flight crew was certified in emergency escape procedures. This is the auto access arm as it was attached to the vehicle once Discovery rolled to the pad last month. And the rotating substructure was then moved into position around the orbiter to allow the installation of the payloads and also access to various parts of the vehicle for
Countdown will be initiated in 15 seconds. In 10 seconds. 5, 4, 3, 2.
The rotating surface structure is pulled away, revealing the shuttle as the countdown reaches its final phase. 6 hours before liftoff, all but a handful of workers leave the pad as extremely cold liquid oxygen and liquid hydrogen are loaded into the external tank. Send down slide wires. 9 minutes before liftoff, the countdown is held for a final assessment of launch readiness. The launch director polls the team, and a final go for launch is issued. The countdown resumes. Computers now control the final sequence of pre-launch checks and procedures. In the final minutes, the crew access arm and beanie cap swing away. Just before ignition, 300,000 gallons of water are injected into the engine exhaust to muffle the sound and protect the area from rocket flames. Sparklers ignite under the main engines to ensure that no hydrogen vapors are present. Main engines fire. 6 seconds left until liftoff. Still attached to the platform by 8 bolts with explosive nuts, the shuttle bends forward and then back. Umbilical systems and the hold-down bolts must remain attached until the final moment, just in case there is an engine cutoff, which aborts the launch. Simultaneously, the solid rocket boosters are ignited. The 8 explosive nuts detonate, and the umbilical connections release. The space shuttle lifts away from Complex 39 on another mission to explore and develop the frontier of space.
And welcome to Launch Complex 39 at NASA's Kennedy Space Center. This is where it all starts, and what and who makes it happen is what this film is all about.
To tell the shuttle story, you probably think we'd start with a dramatic liftoff, like this. Complete our mission in space, and land on the runway back at the Kennedy Space Center a couple of weeks later. You might think that, but you'd have it all backwards.
The real shuttle story happens between landing and launch. The real heroes are the people on the ground who put their hearts and souls into their jobs so that we can go to places like this and beyond. Without their dedication and attention to detail, the shuttle would never get off the ground. And when you're working in space, hundreds of miles above the planet, you never forget the thousands of hours the Kennedy Space Center ground crew puts in before the flight. As we make our re-entry, the shuttle team ground crew is back at the runway ready and waiting.
I, as a NASA convoy commander, lead an assortment of about 50 vehicles out to the runway, and we'll wait for the orbiter to touch down, its drag chute to deploy, and it comes to a stop. At that time, the convoy will roll out to the vehicle. We'll descend upon it with our 50 vehicles. We'll check on the crew, make sure the crew can get out. We make sure that there's no leaking chemicals, toxic chemicals or vapors coming from the vehicle. We get it stabilized and put to bed, if you would, in the OPF at the end of the day.
In the orbiter processing facility, shuttle team workers will spend the next 4 to 6 months inspecting every inch of the orbiter for damage that may have occurred during the previous flight, making repairs, and getting the shuttle ready for its next mission.
The main job that our guys do here, we remove the engines from the vehicle, we bring the engine over to the main engine shop, we do some extensive inspections on the main engines, we remove and replace some of the components as required, we do leak checks, checkouts, and then we go reinstall the engine on the vehicle.
Since the shuttle was designed to be the world's first truly reusable spacecraft, every inch of the orbiter must be inspected and repaired. One of the most important features of the orbiter is the thermal protection system.
The basic block is made of silica fiber, insulates the aluminum skin underneath to 150 degrees to keep that aluminum from becoming soft. During re-entry, the hot plasma gas that flows around the orbiter gets upwards of 3,000 degrees Fahrenheit, and you need insulation material to keep the aluminum skin of the orbiter from actually melting.
The OPF is also the place where the old payload is removed and the payload bay is made ready for the next trip. You might think of the shuttle as a giant space truck designed to carry payloads into space, as well as scientific instruments used to gather data and conduct experiments in zero gravity.
We're fortunate in payloads to be able to have a new mission, a new customer, a new configuration of the orbiter, both mechanically and electrically each time, and it's never a dull moment, so I simply love this.
Once the orbiter gets a thumbs up from the team at the OPF, it's off to the vehicle assembly building.
To assemble a space shuttle, we start out with the solid rocket motor segments, each of which weighs 250,000 pounds, and stack 4 on each side to make a complete booster. When that part's complete, we get an external tank, which itself weighs 66,000 pounds, and very carefully and precisely put that in between the boosters. And finally, we go to the hangar, get an orbiter, bring it into the VAB, lift it to the vertical position, and attach it to the side of the tank. And that makes up a complete shuttle that you're used to seeing on the launch pad. It's very fulfilling to realize you've put together a very complex machine that's now flying through the air and carrying people into space.
Maybe you'll be lucky enough to see the shuttle on its way to the pad today. Traveling at speeds up to 1 mile an hour, the entire journey from the VAB to the launch pad can take up to 8 hours. The space shuttle arrives at the launch pad about a month before the actual launch date, and it's a very busy month. In the final days before launch, Kennedy Space Center's quality control teams pore over every inch of the shuttle, looking for any imperfection, knowing that even one loose screw could